Okay, a little coordinate geometry today. Let's roll. We got distance formula. You guys remember what that is, right? Distance is equal to the square root of x sub 2 minus x sub 1 quantity squared plus y sub 2 minus y sub 1 quantity squared. So given two coordinates, x sub 1, y sub 1, and x sub 2, y sub 2, that is the formula for distance. You come up with one number. That's the distance between 2 points. The midpoint formula, distance between, or the middle of 2 points in a segment, is going to be another coordinate. So we have a comma in the middle, we have parentheses on the sides. You average the x values, so x sub 1 plus x sub 2 divided by 2, and y sub 1 plus y sub 2 divided by 2. And that is the midpoint formula. So let us plot the points. Let's find the midpoint and the distance between them. Sketch does not have to be perfect, just enough to get a rough idea of where the midpoint might be. Somebody willing to guesstimate the quadrant, 1, 2, 3, or 4. If this is 1, this is 2, this is 3, this is 4. Would you like to estimate where the midpoint is located? I'd say quadrant 4 would be a good estimation. Let us do the midpoint formula. Midpoint formula, we add the x values, and you get -1, and we divide by 2. You add the x values, and you get -2. Divided by 2 is -1. Whoop, I'm sorry. 3 plus -2 is +1, so it's +1/2, -1. Sorry about that. Notice how I caught myself. We said it should be in the fourth quadrant. I ended up in the third. I knew I made a mistake. 1/2, -1. So it look like that's about where the midpoint is located? Yeah, I've checked the reasonableness of my solution. Now I find the distance. Distance, we take the square root of x sub 2, which is 3, minus x sub 1, which is -2, squared, plus y sub 2, which is -6, minus 4, squared. 3 minus -2, 5, squared is 25. And -6 minus 4 is -10. Squared is 100. Square root of 125. Can that be simplified? What is a perfect square divides evenly into 125? 25 goes in 5 times. We have 5 roots of 5. So that's the distance. That's the midpoint. Done and done. You try the next one on your own. Go. People are still finishing up. As you finish up, if you would check your answer, put it up on the board. Okay, something I'd like to show you with this is this kind of connection right here. It's how you can remember the distance formula and make better sense of it. If you check out this distance between these 2 points right here, I want you to notice that what we could do is we could simply choose that as our x distance, choose that as our y distance, and what shape have we made then in that situation? Triangle, what kind of triangle? What applies to finding the distance of the hypotenuse of a right triangle? What formula do you use? Pythagorean theorem. A squared plus b squared is c squared. If you notice, the distance formula is simply that. If I square both sides, I get d squared is equal to the quantity x sub 2 minus x sub 1 squared, which is your x distance, plus y sub 2 minus y sub 1 quantity squared, which is your y distance. So you can see you have a squared plus b squared is c squared. The distance formula is the same thing. Same thing. Okay? So we don't just make up the formula, we take it from other things. Draw the triangle formed by the points 2, 2, 5, 6, negative 3, 2. What kind of triangle is it, and what is its area? It's an excellent ACT problem. I've drawn the triangle. I need to classify it. I'm going to classify it according to its lengths, not the angles. Do you remember the 3 different types of triangles that we have according to length? Good? Equilateral, isosceles, and scalene. A for the day for Jack. People often remember equilateral and isosceles. People often do not remember scalene. So which one do you think you could rule out right away? Yeah, that would seem to be obvious. I'm going to show you a little way to go about this and make the problem possibly a little bit simpler for you. I'm going to first find the length of the hypotenuse to ensure that it is different from the others. And instead of using the distance formula, I'm going to think of it using the Pythagorean theorem. What would be the length of this leg right here? 4. How about this leg here? 8. 4 squared is 16. 8 squared is 64. We have the square root of 80 is that length. What is this length right here? 5. In order to find the length of the other leg, again, I'm going to use the Pythagorean theorem. What is this bottom distance here? And this vertical distance? 4. Anybody know what then the other leg is, or the hypotenuse is? 3 squared is 9, 4 squared is 16, that makes 25, square root of 25 is 5. It's a 3, 4, 5 right triangle, special right triangle. I'm sure you remember all your Pythagorean triples, right? 3, 4, 5. What else? 5, 12, 13. 8, 15, 17. 7, 24, 25. No, okay, all right. So, which kind of triangle is it? Isosceles. You talk with the people around you and see if you can figure out what the area is. Go. Okay, anybody super confident? Alex. 16. Excellent thought. Unfortunately incorrect. Will. 10. How? Area is 1/2 base times height. What is the length of the base? It is 5. What is the height? It is 4. That's it. Piece of cake. Upside down. Now, let's be honest to ourselves. If I didn't draw these there, would you have come up with the 10 or with the 4 on the side? Okay, so anytime you're given a coordinate geometry type problem, very helpful to draw the triangles in place in order to figure out these distances and roll them. Okay, we pause there. We have 2 parts to our lesson today. That's the first part. the circle has center 0, 0, then the equation for a circle is very simple. X squared plus y squared is equal to r squared. Now, this is the wonderful time where a connection should go off in your brain. When I say x squared plus y squared is r squared, that's very similar to what? A squared plus b squared equals c squared. In fact, it's really the same thing. If you consider a circle, I draw a circle here, okay? And I've got a center, and the distance from the center to the outside is called the radius. And we say that you have an x value for that distance and a y value for that distance. Can you see how x squared plus y squared is r squared? That's all there is to it. It's the same thing as the Pythagorean Theorem, which is the same thing as the distance formula. They're all connected, which is why we're talking about them all together right now at this point, which is kind of cool. Suppose that the center is not at 0, 0, but is rather at hk. Then the center is x minus h quantity squared plus y minus k quantity squared is r squared. No big deal. You'll get it. So, example 5 says, write an equation for a circle with the following properties. It has a center of -3, 2, and has a radius of 4. Now, there's some things that we do in math that you don't end up using that much in the future. What you're going to see here today, you use this a lot. So, take it in, full stride. This you're going to need to know, big time. Center is -3, 2. So I plug in the -3 for the h, I plug in the 2 for the k, and I plug in the 4 for r. So I get x what? Plus 3 quantity squared plus what? Y minus 2 quantity squared is 16. Now pause and look at that equation and understand where it came from. Do you see that the center is -3, 2, yet it says plus 3 minus 2? Do you see the change? It's important for you to recognize that relationship. Second of all, notice there's not a 4 on the end there, but rather the squared value is 16. Okay? Now the center is 0, -5, so it's just x squared. There's no minus anything. You can see the center is 0, 0, it's x squared plus y squared. But the y value, we're going to have y what? Plus 5 quantity squared is equal to 1/2 squared is 1/4. You try letter C on your own. Go. Anybody come up with something different than 18? 6. See how we got 18? Okay. Thank you for asking. I have 3 roots of 2 times 3 roots of 2. That'll be 9 roots of 4. The root of 4 is 2. So you get 9 times 2 is 18. EJ, we better? Good question. Example 6, identify the center and the radius of the following circles. What is the center of letter A? 3, -2. What is the radius? 4. What's the center for letter B? 0, -3. What's the radius? Root of 48. What's the perfect square divides evenly into 48? 16 goes in 3 times, so 4 roots of 3. Isn't it nice when the circle is in a form where you can just look at it and know exactly what the center is and the radius is? What about example 7a here? Can you look at that and determine exactly what the center is just by looking at it? No, it's not in the appropriate form. We're going to place it into the appropriate form called standard form, and then we'll identify the radius and the center. And the key to this is to recognize that the standard form has what we call completed squares. Completed squares. So I'm going to gather my x's together, and I'll gather my y's together. I'll put all other values on the other side, and now I will look at completing the square. What number would I add to both sides to complete the square for the x's? 16. So if I add 16 to the left, I add 16 to the right. Y squared minus 12y plus 36. So I add 36 to the other side. X minus 4 squared. Y minus 6 squared is 59. So that means that the center is what? 4, 6, and the radius is square root of 59. Shelby, did you have a question? Okay. Okay. Brecken? Yes. But you're good. You don't have a question. So I look at the term with the x, and I divide it by 2 to get 4, and I square it to get 16. 12 divided by 2 is 6, square is 36. Got it now? Good question. The next one, what do you notice is different about this one? Yeah, so we just got x squared. So that square is completed. So that means the x value of the center is 0. Plus y squared minus 6y, and then I drop the 7 on the other side. What do you add to complete the square? 9. So we have x squared plus y minus 3 squared is equal to 16. What's the center? 0, 3. What's the radius? 4. Last example is number 8. Then you'll be able to finish your assignment. Find an equation whose center is -1, 2 that passes through the point 7, -13. Talk amongst your peers. Give it a minute and a half. See what progress you can make. Try to have something written down on your paper. Anything at all. Go! Very nice. Okay. Everybody should have x plus 1 squared plus y minus 2 squared written down on their paper, hopefully, or at least in your brain. That's something you're like, hey, I think I could have done that. But the question then is, what is the radius? Does anybody have a plan for figuring out the radius? Distance formula. So if you do the distance formula, notice what happens. You do 7 minus -1, which is 8 squared, plus -13 minus 2, which is -15 squared. So you get the square root of 64 plus 225. You all know what 64 and 225 make. That's 289. And you all remember the square root of 289 is 17. So tell me, what do I put here? 289. Biggest mistake is people put 17. 289 goes there. Now, isn't it interesting that we made the connection between all three? The distance formula is really the same thing as the Pythagorean theorem, right? And the Pythagorean theorem is the same thing as a circle, right? So I mean, a circle and the distance formula are really the same thing too, aren't they? Interesting. You use the distance formula here. The equation for the circle is right here. Watch what you could have done. What's 7 plus 1? Squared? -13 minus 2. -15 squared, 225. So this would have done the same thing for you as well. Math is all connected, isn't it? It's all beautiful. You can finish your assignment. Good job, guys.